everyone, and welcome. Today we're going to talk about sound!
When it comes to us Canadians, we definitely like to be loud and make noise, especially at hockey games and sporting events and on Canada Day when we're celebrating watching the fireworks. So I have an experiment to show you how to be even louder, which I'm sure your parents will love. And this is something you can do at home too. So all you'll need is a can or a cup, and it could be any size, and all you have to do is cut a hole in the bottom and attach a string like I have here. So I just tied a knot in the string, put it through. You might need a parent's help to cut a hole in the bottom. And then you actually have a noise maker. So let's show you how this works. All you need to do is wet your fingers and pull down. You have to squeeze really tight and you get a funny noise. It almost sounds like a fart, which is funny. Now, depending on the size of your can, you're gonna get a different sound. So let's try the second one. That one's really loud, which is great. And then finally, this one is pretty big. This is a coffee tin, and I have a different string too, so you can test out different things. That one's really loud and tinny. Now, why does this work? Well, it has to do with sound. So sound is actually a vibration. So right now when I'm talking, my vocal cords are vibrating the air coming out of my mouth, and it's going through the air, and when it hits someone's ear, it's vibrating the inner kind of bones and cochlea inside of your ear. That way we can hear it. So what would happen if I touch this without wetting my hands? Let's try the bottom here because the top's wet. You don't get any sound, and that's because you're not causing a vibration. When you get your hands wet, you're causing friction like that, and it's kind of tugging and creating vibrations that travel and are pretty loud depending on the size. Now the can acts like an amplifier. So if you've ever seen a speaker, or when you're trying to talk really loud, you talk like this, it amplifies that sound to make it really loud. So you can make one of these, head outside, and make lots and lots of noise for Canada Day.
To start, you need a plastic straw and a pair of scissors. What we're going to do is we're going to flatten the end of the straw, and you're going to cut a triangle into the end of the straw. You just need 2 cuts. And you're going to flatten it really well. And that's about it. The cut part in your mouth and blow. You'll have to play with the angle of the straw for it to vibrate properly. You can use different lengths of straws to get different notes. You can try different lengths, different widths of straws, and see what notes you get. Try not to annoy your parents too much. Our next experiment, we are going to make a popsicle stick harmonica. What we need for this is 2 popsicle sticks, 2 elastics, 1 or 2 toothpicks, wax paper, and a pair of scissors. To start out, cut a piece of wax paper to about the same size and width as your popsicle stick. Then we're going to sandwich our wax paper between the 2 popsicle sticks, and we're going to elastic them together on one end. Next, we're going to take our toothpick, we're going to put it in between our popsicle sticks to create a space and break it off, and elastic those ends together. Take the rest of our toothpick, put it into the other side, break it off again. Have our harmonica made of 2 popsicle sticks with wax paper in the middle with some space created by our toothpicks. It doesn't really matter if your toothpicks are below or above your wax paper. What we're doing is creating space for your wax paper to vibrate. To play your harmonica, just blow. If you have small toothpicks, you can make a harmonica too, but we'll play a different note. At home science.
Some rocks, when they're mined, begin to release gases. The gases are made from the actual physical rock, breaking apart, changing from being part of the rock to being a gas called radon. It spreads out and it is highly radioactive. But how can you tell? For example, if this rock here were highly radioactive, I might be in a spot of trouble. Well, that's where technology comes in handy. Devices called Geiger counters count the number of those small nuclear explosions that are happening around the rock and give off a small click whenever they detect it. as you can hear, this rock is not particularly radioactive, so I don't need to worry. But that can't be said for all kinds of rocks. For example, this one is surprisingly dangerous looking, but not very radioactive. That's because radioactivity can be surprising. Sometimes it's things you'd never expect. Here, let me show you. For example, let's look at this lovely piece of pottery. Looks fine and safe, right? Let's see what the Geiger counter has to say. As it turns out, this piece of pottery is covered in a glaze that is made out of the finest high-grade uranium. It's called Fiestaware, and it was made in the United States out of this devastating glaze for only a few years. But as you can see, it's still highly radioactive. If left to sit for millions of years, eventually this nuclear fuel will exhaust itself and become like the rest of rocks in that they don't click very often. So let's put this aside for a few million years. I don't want it anywhere near me.
That I love to do party tricks. So if you've ever had a summer party, usually you have people in your backyard, you're playing all kinds of yard games, but my favorite trick is to do something called a vortex cannon. So I'm gonna be able to knock these cups over using a vortex ring. Can you believe it? So you're gonna have to keep your eyes peeled because this is gonna go by really quick. Are you ready? Oh, this way. How does this work? Let's talk about it. Okay, are you ready? Can you see that? This is what the air coming out of my vortex cannon looks like. It's actually a circle. And that's happening because the air is actually circulating on top of itself, and filling outwards because of this kind of motion that I'm doing. Let's watch. So it's this really cool circle now. Be talking about gases in general. So when you think of a gas is actually something that takes up space. So when you're breathing out air, which is a gas, it's taking up space in the room, even though you can't see it. So if I tried to squish my hands together, that weird noise you get is the gas escaping. So gas takes up space. So let's do a little experiment to prove that. Now, first and foremost, we're gonna make an experiment that releases gas. So you've probably done this at home. You put some baking soda and vinegar together in a container, and you make a bubbly mess. Now this makes a bubbly mess because it's creating gas. So you can see all those bubbles. That is carbon dioxide, a gas being created. Now I'm gonna show you a different way that I can make carbon dioxide, and it's using something called an Alka-Seltzer or an antacid. Now when you mix an antacid, which is sometimes your parents have these if their tummy hurts, if you mix this with water, it also creates a gas. So watch this. Can you see all those bubbles being created? Now, right now, the gases that I've produced are leaving these containers, but I want to prove to you that they take up space. So what I'm going to do is I'm going to use this tiny little container here. I'm going to add an Alka-Seltzer inside. I'm going to add water, and then I'm going to seal the top with a balloon, and we're going to watch to see what happens. So here we go. Add a little bit of water. Okay. Add my balloon. Now let's watch. Turn it around so you can see. Can you see that? My balloon is inflating. So I'm going to put my goggles on in case this pops. But you can see that the gas being produced is all being held inside of this balloon, which is amazing. And you could try this experiment at home. You just can use a water bottle and then put a balloon on top after. So now that we know gases take up space, I've got a really fun experiment for us. I've got our experiment set up. So you'll notice I've got all these little containers, the same kind that we use for our balloon experiment. Look how big that is. But this time what we're gonna do is we're gonna add water and our Alka-Seltzer, but we're gonna seal the top. So we know that our kind of Alka-Seltzer and water makes this much gas, but if that gas can't escape, what's gonna happen? Well, it's gonna go pow and explode. But I have a question for you, and you're gonna make a hypothesis. Do you think the container that has more Alka-Seltzer, so a full piece like this, will go faster or explode quicker than that one that has less Alka-Seltzer? Well, there's only one way to find out. I want you to think of your answer right now, and we're gonna try this experiment. So I'm gonna add the same amount of water to each of these. I'm gonna close the lid so you can see I've got a full piece, a little bit less than a full, almost a half, a quarter, and a tiny little chunk at the end there. We're gonna seal these up and see what happens. So I'm gonna put my safety goggles on. Let's start it up. I'm gonna add a little bit of water. Perfect, perfect. Make sure they're even. Okay, now I'm gonna add the lids. So how to do this, I'm just gonna close it and push down, but they're not gonna react yet because they're stuck to the top. So I gotta be careful that they don't touch the water or they'll start to make gases without me wanting them to. Okay. Uh-oh, I don't think that one has a good seal. That's okay. Okay, are you ready? We're gonna shake them and spin them. Oh, we lost our seal on that one. That's okay. We're gonna watch the other one. So this one's out of play. Let's watch the other ones. Which one do you think is gonna go off first? I think it's gonna be this side. Okay, so it happened to be this one. Interesting. Let's watch what happens next. Oh, I can see these ones don't have a very good seal. Oh! Did you see how powerful that was? This one had so much more Alka-Seltzer and it created a bigger explosion. Okay, next. I don't know what's gonna be next. I'm a little nervous. This one. I'm gonna make holes in the roof. Okay, that's okay. Science is a little messy sometimes. Who's next? And anything coming from our last guy with our least amount of water? I'm a little nervous. Let's wait, let's see how long it takes. Well, I think I give up. I don't think this one's gonna go off. I can see that the gases are being created, but I don't think it's enough to be able to pop the lid. So what happened here? Well, we had our second one go off first, and that's probably because it had a really good seal. But for the most part, our Alka-Seltzer and tablets on this side of the tray went off first, and that's because they had more substrate in the reaction, and they were way more powerful. So this first one that went off kind of was a slow dud, and then these ones were insane, crazy fast, and probably made a hole in the roof, which is really neat. So from this experiment, we learned more substrate or more stuff that we put in a reaction, the faster it goes, and in this case, the more powerful. Okay, so after a little bit of digging, I figured out that the reason fireworks can change color is the same way that those little fire packs you get at the store can change the color of your fire. So I'm gonna use a bunch of different kind of substances here to try to change the color of fire. Now, if I wanna start a fire, the very first thing I need is fuel. And my fuel here today is called methanol, and I've chosen this because it burns clear. Now, usually when you light something like a match or a lighter, it has a bright yellow flame, but I don't want my flame to have color. I want it to be clear. So this will be our control in our first container to show us what just our fuel looks like with nothing else in it. Next, I have stump remover, potassium iodide, borax, calcium chloride, and table salt. And I'm gonna mix each of these with a little bit of fuel or methanol, and then I'm gonna light it on fire and see if we can get different colors from each of these. So let's fast forward. I'm gonna add my methanol to each of these, and then we'll set them on fire. Okay, we're ready. So I'm gonna shut the lights off and then we're gonna light these up. Are you ready? Put my protective equipment on. I've got my fire extinguisher ready, just in case. Remember, don't try this at home. Okay, let's give these a second. Can you see that? We've got blue, purple, green, and more of an orangey color at the end. This is amazing. Let's zoom you in and show you what it looks like a little bit closer. So the blue in our stump remover is from the copper that's present, and that burns blue. We've got potassium in our second solution, and that burns purple. We have a little bit of barium in our third one, and that burns green. And then our last two have calcium and sodium, and those burn orange. Okay, that was really cool. To make a fire tornado, what we need to do is take this sponge that I have at the bottom of my basically garbage can on a Lazy Susan, and I'm gonna soak it with lighter fluid. And lighter fluid, like I said, burns bright orange, so we'll be able to see it. And I'm gonna put this back on the bottom. I'm gonna light it on fire and spin it, and we're gonna get a fire tornado. And fire tornadoes actually happen in real life when you have forest fires and big gusts of wind that kind of oxygenate the bottom and it sends it upwards. So let's shut our lights off, put our safety equipment on, make sure we've got our fire extinguisher ready, and see what happens. Okay, we've got a good flame now. We've just got to turn it. Can you see that? This is incredible. So this is a fire tornado. We're getting oxygen going from all angles because we're spinning it, and it gets sent upwards to the sky. I've got one last fire experiment for everyone because I know we love fire experiments. This time we're going to use a different fuel, and it's called butane. Actually a gas, and a gas is something we talked about earlier. It's floating around us, it's in particles. And I want to be able to hold on to this gas so I can set my hand on fire, which sounds scary. And again, I'm trained to do this. So how exactly can I hold on to a gas? You can't really grab it, you can't hold on to it. So what we're gonna do is we're gonna use bubbles. So we're gonna trap our gas in bubbles. I'm gonna hold on to it and then set it on fire. So for this experiment, what I have is a bowl of cold water, and what I'm gonna do is pour some of my soap in the bottom, like this. And then all I have to do is take my butane, flip it upside down, and push it on the bottom of this bowl, and it's gonna create bubbles. So listen. Can you hear that? So now we've got all kinds of bubbles on the bottom of our container, and I'll show you in a second. But first, I like my arm hair, so I'm gonna put on my gloves, and I'm gonna put on my shield, and I'm gonna shut off the lights so we can see a little bit better. So let that clear up. Okay, so I'm going to light my match, hold on to the bubbles, and set it up. Did you see that? So all of that butane that was trapped inside of those bubbles lit up really quick, and as soon as it got ignited, it disappeared. So let's try that one more time. We're gonna put a little bit more butane in the bottom of our container. I'm gonna get a new match. I'm going to put my safety equipment on, my headgear down, light my match. Oh, I broke my match. Let's try another one. There we go. Grab my butane bubbles and light it up. And just like that, I can catch my hand on fire in a safe manner. Again, don't try this one at home. I'm a trained professional, but that's one of my favorite fire experiments of all time.